Hello everybody, we're going to take another look at solving using the quadratic formula in this video. So how do we use that formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the formula that we're going to be using to solve our equation today to get our two solutions. So let's take a look at this problem right here. What's really nice about the quadratic formula is that it won't matter what these coefficients are. You can keep this as a 4, an 8, a 1. This could be 40, 80, 10. It doesn't really matter as long as you can recognize the a, the b, and the c. Now remember, the a, the b, and the c are the numbers that we see in this problem that are the coefficients and the constant here. And they have to be in these same locations, okay? The a always has to be in front of the x squared. The b will always be the number in front of the x, and the c will always be that constant term. Now, if for some reason there were some terms over here on this other side, we'd want to make sure that we move everybody to one side, combine any like terms before we even start using the quadratic formula. Okay, so let's take a look. We would have the formula negative b plus or minus the square root of b squared minus 4ac all over 2a. And now if we apply that formula to this problem, let's go ahead and do that. So in this problem, I have a b of negative 8. So if I'm going to negative a negative b, he now becomes positive 8. Then I'd have plus or minus square root the b squared, so I'd have negative 8 squared, minus 4, then the a, then the c number, all over 2 times the a. Okay, so all the values have been plugged in here now. From this point, now I would focus my attention to all this underneath the square root, okay? This is called the discriminant, but in essence, we're going to figure out what this number is first before we can proceed any further. So if I were to type in my calculator negative 8 squared, that's 64, minus 4 times 4 times 1, 4 times 4 times 1 is 16. I'd have 64 minus 16, which gives me a value of 48. So inside the square root, I have a 48. I still have my 8 plus or minus square root of that 48. Still over the bottom number here is 2 times 4. That's also 8. Now before I simplify anything else, I need to figure out that square root, break him apart using a perfect square. So if I break apart the square root of 48, I would break him apart using 16 times 3. Now you might be thinking, well, wait, I could break it apart using 4 and 12. Certainly you could. It's just that 12 would still need to be broken apart some more. So we always try to divide out the biggest perfect square possible. Okay, so once I've broken that 48 apart, let's see what that would look like. It would become 8 plus or minus, still going to have the over 8 on the bottom, but that square root of 48 now, we're going to change him up. The square root of 16 is 4. The square root of 3 is, I don't know, right? That's the weird irrational part, so we're going to leave that alone. And this is where we are so far. We've broken apart the square root of 48 into 4 square roots of 3. Now, once we've done that part, now we take a look at these numbers here. Okay, leaving the square root alone, we say, what kind of that number can I divide out of those 3 numbers? What number can I divide out of 8, 4, and 8? Can I divide them all by 2? Sure. Could I divide them all by 4? Even better? Yes. Could I divide them all by 8? Nope, 4 doesn't divide evenly by 8. So let's divide all of these by 4. If I do that, 8 divided by 4 becomes 2, plus or minus 4 divided by 4 becomes 1, square root of 3, all over 8 divided by 4 again is 2. So I would leave my answer as 2 plus or minus 1 square root of 3 over 2. All right, so that's my value for x. That's what my solutions would work out to become. That's how we apply the quadratic formula and simplify those square roots. All right, ladies and gentlemen, thank you for paying close attention here today and taking good notes. See you later, Sabers. Kincaid out.